Think back to our earliest ancestors. They had three simple directives: find food, avoid predators, and most importantly, survive to reproduce. Evolution is a brutal accounting system. Every action has a cost. So, why in a world full of leopards and poisonous plants did they choose to venture over the next ridge? Why look under that rock? The risk of injury could be death, but the reward is abstract. That is the key distinction. Simple exploration is what a squirrel does. Curiosity is what turns those simple observations into predictive models of the world. And that is the first and the most critical step in building the human civilization. The logical move would be to stay put, conserve energy, and stick to the familiar. Yet, here we are. We are a species built on exploration. This suggests that curiosity is not just a psychological quirk, but an evolutionary imperative. A drive so fundamental that it acts like a curious gene, compelling us to learn, adapt, and invent. In this video, we are going to use the lens of evolutionary biology to ask why was curiosity selected for, and how it will change our species forever. In 1971, a paper was published by Robert Tribble on the evolution of reciprocal altruism. What he showed and depicted was the evolutionary cost-benefit analysis. The cost of exploring a valley is high. On the one side, it requires energy, time, and there are also risks of potential danger. But look at the bright side. What we obtained was the information, which is high yield and long-term asset, which outweighs anything which is on the opposite side. Curiosity doesn't just reduce risk, it creates our earliest forms of technology. The ancestor who was curious about how a sharp rock broke the bone eventually leveraged that information into a tool, and the one who investigated fire's behavior harnessed it. And that is the key distinction. Simple exploration is what a squirrel does. Curiosity is what turns those simple observations into predictive models of the world. And that is the first and the most critical step in building the human civilization. So how does the body enforce this risky behavior? That is through chemistry. Curiosity is tied directly to the brain's dopaminergic system. When we encounter an information gap, that uncomfortable tension of not knowing, our brain creates a mild and an aversive state. The drive to close that gap is immense, and when we get the answer, the brain releases dopamine along the mesolimbic pathway. And this acts as a powerful and a positive reinforcement. The body is literally rewarding the act of learning itself. It's giving you chemical paychecks for being a good informer. Now, let's look at the genetic angle. There's no single curiosity gene, but the genetic variations in the system that handles dopamine affects how we seek novelty. The genetic polymorphisms in the genes like the DRD4 receptors are strongly associated with novelty-seeking behavior, and these are the genes of nothing but the wanderers, the explorers, and the innovators. The evolutionary story is compelling, but it doesn't quite explain us. A rat explores to find food. A crow explores to find a tool. But why did our ancestors look at the night sky and try to map it? This brings us to epistemic curiosity, the desire for knowledge purely for the sake of knowledge, the why that has no immediate survival answer. This leap is the moment the curious gene created science. It forces the human mind to go beyond merely reacting to the environment and start predicting it. It's the drive to build an internal model, a hypothesis of how the world works, and then actively seek data to test or falsify that model. This is the scientific method itself, and it is a direct evolutionary outgrowth of our need to close the information gaps. Consider the first astronomer. Mapping the stars didn't feed them that night, but that act of pure, selfless curiosity eventually gave rise to calendars, agriculture, and global navigation. So to answer the question, Was the human mind a genius invention or just a stroke of luck? It was neither. It was a high-yield evolutionary bet, a gene that despite the immediate risks, guaranteed our species' long-term ability to adapt, invent, and dominate the unpredictable. But now, look at the logical endpoint of this relentless curiosity. In 1990, the Voyager 1 probe looked back from 3.7 billion miles away and took a final photograph, a single pixel of light in a sunbeam. Carl Sagan once looked at that image and said,
"Consider again that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrine lived there, on the mote of dust, suspended in a sunbeam."
The power of the curious gene is not just that it drives us out into the world, but that it compels us to look back at our isolated homes. Acknowledging all the vastness of the universe, there is no hint that help will come from elsewhere to save us from ourselves. And that is up to us. But now, the ultimate command of the curious gene is now clear: to deal more kindly with one another and to cherish and preserve that pale blue dot, the only home we have ever known. And this is the power and the ultimate responsibility of the curious gene.